Hello, this is another sprint demo from the Evernym team that contributes to Hyperledger and Sovrin, and we're excited to share with you our progress over the last couple of weeks. We're at the middle of August, and today we're going to cover our work on PBFT view change. We've been working on this for months. This addresses what is currently the most critical problem with Indy-Node. That view change, there's some corner cases where it could fail, and we're glad to be addressing that concern. We expect that to be released in September. Alex will take us through the progress there. But there's a lot of refactoring that's going to go into August that'll improve the system. We're also going to talk about proof of possession of a payment address. This was a collaborative effort with the team at the Sovrin Foundation, and it'll make it much easier for any future token on the Sovrin network to people to know that who they're trading tokens with is in fact the person who owns that address. So that'll be a nice capability. And then we're going to talk about the vision of the Sovrin network has always been decentralized access. Currently, you have to have an endorser, what used to be called a trust anchor, and approve every write. And in order to make sure things get paid for, the validators get paid, the stewards, and to make sure that the inappropriate content doesn't end up on the ledger. Currently, every author has to be an endorser. That's not very decentralized. So this does finish the work to separate that so that an endorser can improve third-party transactions, and authors can just create their transaction and submit it to endorsers who they have a relationship. And so we're going to talk about how that permission is handled, how the ledger checks that permission, and then how it's how it works on the CLI so that people can do endorsements. And then much requested is for the SDK to work on the latest long-term supported Ubuntu. So we've made significant progress on that. We'll talk about that. The current sprint that we've completed covers that plus some additional bug fixes. We also gave some feedback on how the continuous integration pipeline can evolve over time. We're going to keep working on that effort. We're collaborating with other members of the community, of the Indy community, on that. So that's the key thing we did there. On the SDK side, Artem, Nikita, Sergey got a lot of stuff done. They completed their committed work a bit earlier than expected, and just ticked through a lot of issues that people have raised. So I hope people are as excited as I am that a lot of the concerns people had are resolved. We're going to have the August release is going to be a nice bug fix release. We've addressed a lot of problems there, so thank you for that. And we didn't work much on the Sovrin token. We did create a checker script that can run automatically and say, in these wallets, each wallet does have the amount that we expect it to have. So any deviation from what accounting thinks is in those wallets can be detected quickly. Of course, we'll have other wallet controls to prevent unauthorized access, but this will help us recognize that our controls are working. So we do expect to skip. There's some additional work to do, but not too much. So the next 2 weeks, we're going to focus on getting the release out with as many bug fixes as possible and the PBFT view change work that we've been doing. Not getting it done, but making as much progress on PBFT as possible. So we won't be in this backlog too much this sprint. I have been wondering if, as we've been talking about the Indy Aries split, at some point we should probably start using the Aries Jira and keeping track of our work there. That puts us in 3 backlogs, so we're going to wait a little while on that. And the split is we're still figuring out the architecture there. But at some point in the future, we're going to be using the Aries board for some of what's currently in the SDK. That is the quick review of where we're at. So with that, I'll stop sharing my screen and let Alex take over.
Thank you. Can you see my screen?
Yes, looks good.
Okay, yeah, I'm going to tell you about the current status of PBFT view change. current progress. And let me start with the context about what we are doing and why we are doing this. So Plenum uses RBFT consensus protocol, which is a modification of PBFT protocol. And as PBFT, it's also a leader-based protocol, meaning that there is a primary who proposes the order of transactions to other nodes. And
I know you've told me this lots of times, Alex, but I keep forgetting. What does the R stand for and what does the P stand for?
PBFT is practical and R is redundant.
Redundant Byzantine fault tolerance and practical Byzantine fault tolerance.
Yes.
Okay, thank you. Let me ask you, I couldn't remember.
Yeah. So as you can see, the leader, the primary, can be malicious because of some reasons. There can be, for example, no connection to the primary. It can be shut down. It can be too slow. It can send some invalid data and so on. And if the pool finds out that the primary is malicious, it starts a so-called view change protocol to select a new leader, a new primary. So the current view change protocol implemented in Plenum, it has some deviations from the original paper. And this can lead to some nasty things such as inconsistency of data, of ledgers, which violates the safety property of the system. And also it can be quite slow under some conditions, which affects liveness property. But since RBFT is a modification of PBFT protocol, it assumes that the RBFT should have exactly the same implementation and the same view change protocol as in PBFT. So what we are doing now is that we're fixing this deviation and we're implementing the view change protocol exactly the same way as it's described in PBFT paper. This is one of the versions of this paper that has quite a good summary of this protocol and exactly the modification that we need to use. Okay, so we have short-term goal here and long-term goal here. The short-term goal is, of course, to implement this new view change protocol, PBFT view change protocol, is to integrate it into existing Plenum code so it's working, and of course to make sure that it works properly and correctly. And in order to prove it, we are doing testing on all the levels. It includes unit tests, integration tests, property and property-based and simulation tests, which is very important, and of course system tests and load tests. And it's important to see that the first 3 levels, including property-based tests, are done during development time. So with the help of property-based and simulation tests, we can get any issues quite sooner. Also, it's important to notice that although we are doing the protocol the same way as described in the papers, we have the audit ledger. So you can look at our previous demos for more details about what is audit ledger, why it's needed. But the presence of this ledger, although the audit ledger itself provides a lot of benefits and fixes a lot of other issues, but it requires us to do some small modifications in the view change protocol so that the implementation becomes a bit more complex and we need to take into account other things. For example, the view number of the view is stored in the audit ledger, so we need to keep the view numbers to make all the transactions in audit ledger consistent between views on all the nodes. Okay, so our long-term goal is not only to implement PBFT view change, but also to improve Plenum's architecture and eventually improve the protocol. Why we have this long-term goal? Because in order to implement the PBFT view change, we have to do some necessary changes in architecture, in particular in order to run property-based simulation tests. And these architecture changes can be considered as a significant step to our long-term goal. So as I said, there are 2 items here: improve Plenum's architecture, to improve maintainability, readability of the code, scalability and performance, and also to improve the protocol. It's actually a rather part of Ledger 2.0, but there are multiple options such as fixing other deviations from RBFT protocol, we can have a look. I remind you that we have architecture diagrams, and you can see the current architecture, and by red you can see what needs to be fixed in RBFT. And another options could be to move to another PBFT-like protocol. With the presence of correctly implemented PBFT vchange protocol, it would be more or less trivial task, so we can try other things as well. Okay, so now let's move to the next slide, how we are doing this implementation. There are four main parts here. The first one is modular architecture. And the main goal for this architecture is to have a code, more stable code, which is properly covered by unit tests, and which allows to run and execute property-based tests in efficient mode. And as you can see, the value of this test is that we can get some errors during development time, not when we already have the code in production and do some load testing. And this part is done, I would say almost done. We are finalizing these things this sprint. Second thing is to write this simulation and property-based tests, the second item here, and the main tests are already written. Of course, we expect the improvements, extending and integration, but at least we have the basis. The third thing is improvements in the protocol, which we need to do in order to integrate the new protocol, and this is actually in progress. And the fourth thing is the actual replacing of the protocol by the new one, and it's something that needs to be done. We have the whole epic devoted to PBFT vchange. It's 1302, and you can see that we have a bunch of tasks already complete here, some tasks in progress, and some tasks that we still need to do. Okay, as for the first item here, modular architecture. So on one of our previous demos, we already showed a series of sequence and other diagrams representing this architecture. Let me just quickly remind these. So the essence of this modular architecture is that we have a set of services, quite independent services. This is orderer service, checkpointer service, vchange services. These services, they don't have any dependencies, strict dependencies on the network or on the node or other monoliths. So we can instantiate them independently and execute them by property-based tests, unit tests, and so on. The services are communicated by each other via messages and buses. This is close to something like actor model. And yeah, this allows us to have modular architecture that we can execute tests against. So yes, as I said, the services are communicated via messages and buses, and all of these tasks are mostly done. So we have implemented vchange service with the vchange protocol as described in this paper. We have the ordering service, which is responsible for actual processing of three-phase commit messages, prepares, commits, and ordering. We have checkpoint service responsible for creation, processing, stabilization of checkpoints, which is also a very critical thing for PBFT vchange protocol, and some shared data that needs to be shared between the services. Let me quickly show you the implementation. So there is a new package here. It's called Consensus, and here we have these new services. You can see the vchange service. This is a new code with a new protocol implemented according to the paper, and we have a bunch of unit tests and simulation tests proving that the implementation is correct. And you can see that the input for these servers, there are no any references to some networks or to node class or to replica class. There are just two buses, which is the abstraction for communication between the services, timer service, which is also an abstraction, and the data, and that's all. So it's quite easy to instantiate it. Ordering service, responsible for processing of three-phase commits, checkpoint service, and here we have a set of internal messages between the services and the buses. We have internal bus for service-to-service communication and external bus for communication with other nodes, which will use some network interfaces internally. And yeah, so this sprint we are finalizing the task of integrating the services into existing code base and replacing their replica monoliths. So, and it's one of the quite big changes in August release. Although in August release we don't expect the PBFT change to be fully integrated, we do expect that we will have this split into services. And it's very important that this is not a separate implementation. The services will be already included into existing code base, and this will be a production code. So that's why we chose the approach to use it step by step in incremental thin vertical slices. So the next second thing is simulation property-based tests, and the main properties here is, of course, to make sure that the view change eventually finished. And the second important thing is to make sure that all requests that may be committed ordered on at least one correct node in previous view must be eventually ordered on all correct nodes, so that the ledger is consistent and we don't have the issues that we experience with the current implementation, that the data is inconsistent. So this is very important properties that the tests execute and check. And the requirements for these tests is that the tests must be fast enough, comparable to execution time of unit tests, because we run thousands of runs for these tests to make sure that they work for different input data. And on the other hand, they must be as close to production as possible, because we don't want to, we would like to take into account specific of plenum, including audit ledger and so on. So that's why they use the same module services as in production, and that's why we did this split to services: ordering service, checkpointer, and view changer. So exactly the same implementation is used in property-based tests, simulation tests, and in production. And they use real ledgers and states. The only exception that they use in-memory storage for speed up these. And class of code for this test is this one, test sim view change. You can see it here. And by the way, besides these simulation tests, there are a bunch of other tests for the services. So if interested, you can have a look at the code. Okay, so and the last thing here is improvements in the protocol. And there are three main things that we would like to improve. The first one is to use audit ledger for checkpoints, because as of now, checkpoints are calculated against the digest of requests in this checkpoint, but with the presence of audit ledger, it's more natural and more safe to use the root hash of the audit ledger, because it must be consistent. It doesn't depend on the number of requests that checkpoint is started with. You can find more details in this ticket. The second thing is to enable full ordering of batches, because the essence of the new PBFT change is that requests and batches from the previous view needs to be reordered. The prepares and commits needs to be resent in the new view, even if these requests and batches are already ordered. So this is the second improvements. And the third improvements is that in the PBFT change, in the PBFT protocol in general, it's assumed that the sequence number associated with each prepare, with each batch, is not reset. It's always incremental. But in plenum, it's usually reset to 1 in the new view change. As it's also something that we need to change, we need to fix. So more details can be found in these tickets and in the POA documents in the epic. And the last tasks that will be done, most probably in September, is end of August and September, is actual integration of the new view change, replacing the old protocol and executing these by simulation tests and load tests. So I think that's all from my side. Any questions?
That was really helpful. Thank you for taking us through that. And if anybody does have questions, reach out on Rocket Chat and we can discuss this in more detail in 2 weeks in our next sprint demo. Of course, we'll try to answer questions as well. So that's chat.hyperledger.org. So with that, Nikita, you can share your screen.
So we implemented 2 new calls in VCX and in Living. Can you see my screen or not?
It's all black. Maybe try it again. Come on, zoom.
Yeah.
It flashed up for just a second and then stopped.
My. For some reason, it doesn't work. Again, it just flashed.
Let's go to Vladimir and
Yeah.
Artem, and then we'll come back to you, Nikita.
Yeah.
And you can maybe you'll have to close Zoom and rejoin.
Can we start with Artem, please? Because I also now rebooting my virtual machine for the demo.
Yeah, that's the way it goes some weeks. Artem, is that okay?
Yes, okay, I'm ready.
Thanks.
Hello everyone. I'm going to show a demo how we integrated Endorser workflow into Indy CLI and V6. I would like to start from CLI. So here I have two windows. In the first one, I have NDID with an Endorser role, and the second one I have NDID with just a regular user who doesn't have a role on the ledger. So first of all, I would like to remind that endorsing is the publishing transaction to the ledger, preserving an original author. Indy CLI supports four different commands, transactions which can be endorsed. This transaction is name, attribute, schema, and credential definition. So in this demo, I'm going to publish schema transaction to the ledger using Endorser overflow. First, I'd like to remind to publish schema transaction. You either need to have an endorser or trusty role. Regular user can publish transaction. We can try, but we will get reject. Let's try. Yeah, we got an error in typical setting, and now I will show how to endorse this transaction. I'm copying the same command, but I'm going to append one additional field to this copy. It's endorser field, and here I'll copy the ID of a user with endorser role. I'm posting it here. Appending endorser parameter to schema transaction implies that this field will be appended to transaction. This transaction will not be published to the ledger and will be printed in output and stored in CLI context. So transaction has been created. Now I'm going to save it into a file to be managed to use from endorser side. Let's call it txt. Yes. Okay, transaction has been stored. Let's check. Yeah, here we can see a transaction stored in the file. And now I'm going to move to Endorser CLI. Now I'm going to load this transaction from a file. Wrong. Ledger, load transaction, file. Let's copy file path from here. Put. Okay, transaction has been loaded and stored in CLI context. And now to endorse this transaction, I need to put ledger endorse command. This command has one parameter takes in. This parameter can be skipped. If you are going to use transaction stored in context, like in my case, so we just tap enter. Here we have a confirmation where we can see the transaction. I put yes. Yeah, transaction has been published to the ledger successfully. Let's check it from the user console. Ledger get schema DID. I would like to also note that original identifier of this transaction is the ID of my author. Schema, name, person, this. Okay. Yeah, transaction has been published. So next I would like to move to libvc side. The workflow libvc support endorser is pretty similar to Indy CLI, but there is a bit difference. Originally, VCX has had only one function, for example, for credential definition, which does creation and publishing transaction. We added a new one function to prepare transaction for endorsement. And now this workflow will look like we call this function to build transaction, and internal object. This function will return two parameters. The first one is a handle, which can be used later for issuing credentials. The second one is transaction JSON, which should be transferred to an endorser. To transfer this JSON, you can use connection send a message. This function allows sending a generic message to remote connection. Next, an endorser should, when receives this message, should use v6 util function, v6 endorse transaction. This function append the endorser signature to a request and publish to the ledger. After that, an original author should call v6 update state function to check if transaction has been published to the ledger. And if it has been done, so in this case, the state of internal object will be changed, and this time we can use a handle for issuing credential. That's it. The same workflow is implemented for schema. Using v6, you can endorse only two types of entities. And at the end of my demo, I would like to announce that for this time, we have started publishing and building Debian packages for Ubuntu 18. You can install these packages the same way as for Ubuntu 16. You can use apt for this. The only difference is you need to specify a different channel. Instead of Xenial, you have to put Bionic. These artifacts can be found in reposovrin.org. And for now, we have only the development type of builds. That's it. Thank you.
Thank you, Artem. That was really great demo, answered all my questions, and I'm really excited to have Bionic packages. I don't have to build my own anymore. That makes me nice. That's very nice. Vladimir and Nikita, are either of you have systems work?
I'll try.
Okay, let's see Nikita's. Cross our fingers the Zoom works.
Damn. What was that?
I don't know why it's doing that.
I'll try on the other screen. Try again. It flashes and it just goes.
Maybe I can open a file you are interested in.
Yeah. So I'll drop it.
Well, Nikita and Artem gives it a shot on Artem. Oh, look, it's working. So is that Artem's machine?
Yeah, it's here. Yeah, it's from right now. It's from Artem. Yeah, so we implemented two calls in VCX. So it's VCX wallet sign with address and VCX wallet verify with address. It's a little bit lower. So these are two calls that lets you prove the possession of payment address. They will call to the plugin methods that are called the sign with address and verify with address, and they will make some proof plugin dependent that you have this that you really own this address in your wallet or somewhere. What about libs of token implementation? It will take the payment address and it will make a signature over the data that you pass to the sign method. And then to the verify method, you should pass the signature that was made, that was sent to you, the message that was signed, and the payment address it was signed by. You don't need to have a payment address to verify it, in your wallet. So that's it. And now I'll try to launch my to launch. It doesn't work as well. For some reason, I don't know why it doesn't work. I want to show the CLI example. Artem, do you have a build CLI right now?
Yes, I can show.
I can move to your.
Good thing you guys sit next to each other.
I can see.
Well, you switch we want to call out that Mike Lauder had the idea to implement this and did a chunk of the work. Mike Lauder is the security maven at the Sovrin Foundation. And it's fairly nice that when you need to know, when you're transferring funds, it can be rather nerve-wracking. You want to make sure you have the right payment address, that there's no typos, that it is in fact going to the person you think it is. And so this helps with that. So it is a nice set of features. I appreciate Nikita collaborating with Mike to do that.
Нету плагина.
Чего нету, ты опечатался.
Да.
Okay, so you loaded LibSoft token?
So I'll continue from there. Yeah, it'll switch. So we have loaded the plugin. Right now I'll make a new wallet. So I'll make a payment address. Yeah, and payment method. Yeah, here it is. And then I'll send some data. Он есть, что ли, да? Я все так вот делаю по старинке. We generate a signature. Then we will move to the other one and just try to verify it.
So you've signed that input.
Yeah, I've signed an input, and then I'll try to verify it.
So the idea is that the verifier generates that input and hands it to the owner of the payment address, who then hands it back and says, "Look, this is in fact me." So it can be a random string of some sort.
Yeah, it works that way. Yeah, here. Payment address, sign. Yeah, verify. Signature. I will copy it from here. Address there. And input. I'll type it in. Yeah, and it says it's valid. We can try and if we give another input, it says invalid. So that's it.
That's excellent. That's really useful. We'll be using that more. And you took us through the libVCX function, so that'll be really good when we implement that in Evernym's Connect.me. Thank you, Nikita, for making that demo work even under under painful circumstances, and thanks, Artem, for helping. Vladimir, do you have your machine up?
Yes, let me share my screen. Can you see it?
Yes.
So I want to tell about a couple of endorser changes. So our endorser field now must be explicitly present if transaction is trying to be endorsed with a multi-signature, and endorser should have must have an endorser role. So as you can see, I have a default trustee. I've already added endorser to the ledger, and I also have a non-identity owner deed. So now I'm using identity owner deed to create schema with a default trustee DID as endorser. So now I prepared this transaction, and I'm going to endorse it using trustee. Now we have a special command, ledger endorse, that can work with a transaction in the CLI context, as you can see. And I have an error from the ledger, so I have not enough endorser signatures since I've used trustee, not endorser. Now I'm trying to create schema without any endorser field, and I want to sign it with the real endorser. And I've got another error from the pool about absence of the endorser field. So we have a transaction signed by endorser, but without endorser field. And now I create schema common way with the right endorser field and signing it with the real endorser. And now I got a successful message from the pool that I have just successfully endorsed the schema transaction. So that's all from me, I believe.
Thanks. That's a simple demo, but it shows a key piece of functionality. When we talked to the Sovrin governance working group about how should this work, they felt like the endorser needs to be explicitly set. It has to be the person who has that relationship with the network governance, the endorser relationship. So we can't allow trustees or stewards or definitely transaction authors to endorse transactions. So we do explicitly check that the person who's endorsing the transaction does have, the DID endorsing the transaction does have the endorser role on the ledger, and that meets that use case. So thank you, Vladimir, for taking us through that. We have gone a little bit over time, but I think it was really useful information. The next sprint on the SDK side, we're going to start looking at DID doc support. We're also going to work on the fully qualified support for fully qualified DIDs. So we'll go through that and be able to share that in our next demo, along with an update on the release. On the Indy-Node side, we're going to stay focused on PBFT view change. We got to get that done for September, and there's some bugs we want to clean up for the August release. So that'll be nice too. So again, if anybody has questions, reach out to us at chat.hyperledger.org, and we'll try our best to help out. Thank you.